All network devices on the same network must have a unique MAC address, and this is because based on the MAC address of the device, data is directed to the proper destination device. And you can find the MAC address burned into the NIC, so that's why it's also referred to as the physical address. A MAC address is expressed in a group of hexadecimal digits that are organized into pairs or quads. You'll often hear people shorten the term hexadecimal to simply hex, and we'll go ahead and do the same thing. So hex is a numbering system with a base of 16. This means that it uses 16 unique symbols as digits. The decimal system that you'd use on a daily basis has a base of 10, which means that it is made up of 10 unique symbols, or 0 through 9. The valid symbols in hexadecimal are 0 through 9 and A through F, and in decimal, A, B, C, D, E, and F are equal to 10, 11, 12, 13, 14, and 15 respectively. Each hexadecimal digit is 4 bits long, because it requires 4 bits in binary to count to 15. Now, because a MAC address is made up of 12 hexadecimal digits, it is 48 bits or 6 bytes long. If we go to our example, here the 9th and 10th symbols of the MAC address are 2 and E. 2 in hex equals 2 in decimal, which in binary is 0010. E in hex equals 14 in decimal, which is 1110 in binary. So, this byte in hexadecimal equals 00101110. Now, you've probably seen a MAC address represented in different formats. For instance, you can use dots after each 4th symbol, or you could also use colons or dashes after each 2nd symbol. So, we said that a MAC address is made up of 12 hexadecimal numbers, which means it has 48 bits. And these 48 bits are divided into 2 parts, or 2 main components of a MAC. The first 24 bits constitute the OUI, which stands for Organizationally Unique Identifier. The last 24 bits constitute the vendor sign end station address. The OUI identifies the manufacturer by NIC. Let's say it's either Cisco or Apple, but someone has to regulate the assignment of OUIs, and that is the IEEE. Of course, each MAC address for each device needs to be unique. Vendors take care of this in the vendor assigned portion of the MAC address, and this portion uniquely identifies the Ethernet hardware. The MAC address identifies a specific device on a LAN, and unlike other kinds of addresses that are used in networks, MAC addresses should not be changed unless there is some specific need. So basically, having the source and destination MAC addresses allows communication to happen in a network. Actually, there are different types of network communications, and in general, in the networking world, we have 3 types of network communications: unicast, broadcast, and multicast. Unicast communication is just a regular communication between 2 networking devices, where one host sends a frame that's addressed to one specific destination. In a unicast transmission, there is only one sender and one receiver. Unicast transmission is the predominant form of transmissions on LANs and within the Internet. Broadcast communication, on the other hand, is a communication in which a frame is sent from one address to all other addresses. In this case, there is only one sender, but the information is sent to all connected receivers. And in this way, some protocols can send the same message to all devices on a LAN. The last type of communication is called multicast. In multicast communication, information is sent to a specific group of devices or clients. So, if you send information to a client group, only the clients that are members of that group receive that traffic, and the ones outside that group do not get that traffic.